Welcome back to A-Level Mathematics. In this lesson, we begin our study of quadratic equations and inequalities. A quadratic equation in which the highest variable is 2. Its general form is ax squared plus bx plus c equals 0, where a is not 0. Let's begin with a simple example. If x squared minus 9 equals 0, then x squared equals 9. Therefore, x can equal either 3 or negative 3. Many quadratic equations can be solved by factorisation. For example, x squared plus 5x plus 6 can be written as x plus 2 multiplied by x plus 3. Using the zero product principle, if two factors multiply to 0, at least one of them must be 0. Therefore, the solutions are negative 2 and negative 3. When factorisation is difficult or impossible, we can use the quadratic formula. This formula works for any quadratic equation written in standard form. For example, in 2x squared plus 3x minus 2 equals 0, a is 2, b is 3, and c is negative 2. The expression b squared minus 4ac is called the discriminant. It tells us how many real solutions a quadratic equation has. If the discriminant is positive, there are two distinct real roots. If it equals 0, there is one repeated real root. If it is negative, there are no real roots. Now let's move from equations to inequalities. Instead of finding values that make an expression exactly equal to 0, we find a range of values that makes an expression positive or negative. Consider x squared minus 5x plus 6 greater than 0. First, factorize the quadratic to obtain x minus 2 multiplied by x minus 3. We then divide the number line into intervals, using the roots 2 and 3. Testing each interval reveals where the product is positive. Therefore, the solution is x less than 2 or x greater than 3. The endpoints are excluded because the inequality is strictly greater than 0, 0. We can also solve quadratic inequalities graphically. The solution to a greater than 0 inequality is found where the parabola lies above the x-axis. Remember that the sign of the coefficient of x squared determines whether the parabola opens upward or downward. This affects the regions where the quadratic is positive or negative. To solve quadratic equations, we can use factorization, the quadratic formula, or completing the square. For quadratic inequalities, we factorize, find the critical values, and analyze the intervals. Now test your understanding. Solve these quadratic equations and inequality, and use the discriminant to determine the number of real roots in the final question. The key ideas are simple. Factorize when possible, use the quadratic formula when necessary, use the discriminant to analyze roots, and use intervals or graphs to solve inequalities.
Thanks for watching. Subscribe to Unique, like, share, and comment. Keep practicing, and I'll see you in the next A-Level Mathematics lesson.